In this problem, we are going to show that if z equals to r times e to the power of ix, then the conjugate of z equals to r times e to the power of negative ix. So, z equals to r times e to the power of ix is known as Euler's formula. And by Euler's formula, it states that z equals to r times e to the power of ix, which equals to r times cosine x plus I times sine of x. So we have the conjugate of z would equal to the conjugate of r cosine x plus ri times sine of x. And then, by definition of a conjugate, this will equal to r times cosine of x minus r times I times sine of x. And then we can factor out the r. So this is equals to r times cosine of x minus I times sine of x. Then notice that there's a negative here. But then by properties of cosine and sine, we know that cosine of x equals to cosine negative x, and sine of x equals to negative sine of negative x. So if you replace this back in, we have the conjugate of z equals to this, which is r times cosine negative x minus I times negative sine of negative x. And then this will mean that the two minus signs cancel out, so it becomes r times cosine negative x plus I times sine of negative x. And then this is in the form of r times e to the power of negative x of negative ix by Euler's formula. So that is how you should prove that the conjugate of z equals to r times e to the power of negative ix.